Okay, we had a chance to look at what point slope form looks like. Now we're going to actually work through one of these together. So they look a little scary at first. They're not as bad once you do them a couple times because you're always doing the same thing. So it's just kind of learning, you know, like riding your bike. You're going to learn the process and we'll get better at it. So, okay, so our goal is to determine a y-intercept algebraically. I created a graph here where we have two ordered pairs. And what I'm going to ask you to do is just to use a straight edge to connect those together. So if you need to go grab a ruler, that's fine. Otherwise, you know, you can just use the edge of your paper. Okay, so I drew the line through my 2 points. And what I want you to look at is we really need to figure out what this point is. It looks like it falls between 1, 2, 3, 4, somewhere between 4 and 5. So if I had to estimate that y-intercept, I would say it's maybe like 4.2 units. I didn't put any units here, so with algebra, again, lazy mathematicians, you don't have to include your units here. All right, now, for my slope, we already know how to do this. So if you want to come down in this space here, I just recorded the ordered pairs because my screen, doesn't allow me to access both parts of this so you can view both parts. But for our slope, remember we're taking y minus y. So I'm going to take my y values of 5 and negative 4 and subtract them. 5 minus a negative 4. And then in the denominator, I'm going to take 1 minus a negative 12. All right, and so we end up with, looks like 9 in the numerator over 13 in the denominator. And so our slope is 9/13. Since we don't have any units on this problem, you're just going to leave it as 9/13. And so I'm going to label that as my slope. Remember, slope is represented with the letter M. All right, so this number is going to get substituted in to our model right there. All right, so we got our M figured out. We got our slope determined. On the math model here, this part's not written on your paper. So go ahead and take a minute to write this math model. Pause the video, record that, and then we will go ahead and substitute in all the parts that we need to write our math model. Okay, so you've had a chance to record what you see here. Notice what I'm going to do is pretty much just copy right down below this, the same equation. The only thing we're going to do is fill in numbers where you see the number signs. So y1 and x1 can be either of these ordered pairs. I don't care which one. I'm just going to use this set. And so I'm going to call x1 the x value for my ordered pair. Sorry, trying to get a good color here. So let's say this is my x1 and this is my y1. I could have just as easily made this my x1 up for negative 12 and negative 4 my y1, but it's up to you. You get to decide. All right, so again, I'm going to color code just to keep this organized. If you want to grab a crayon or marker off the back, it's not a bad idea. You can pause this and we can do that. So I'm going to just color code so I know that the x value is going to go right here. And I know that my y value is going to go right there. All right, so y minus, notice that minus got copied from up above. And now I'm on the blue part. Well, if I look over here, y1 is just the number 5. Y minus 5 equals, M stands for slope, and we already got 9 over 13 on that. So I'm going to fill 9 over 13 in for my slope. And then inside our parentheses, we have x minus whatever my x1 value was. In other words, the x value for my ordered pair. All right. Okay, you've done the hardest part. From here, it's really just what we did with literal equations. Now we want to get the y value by itself. So I'm going to take this same equation. Oops. And we're going to rewrite that down here. And what we're going to do is two things. All right, first thing we're going to do is distribute. Distribute the slope. I would put that in the notes. All right, so if I distribute the slope, we end up with nothing changes on the left. So y minus 5 equals 9/13 x. And then minus, well, if I take 9/13 times 1, I just get 9/13. All right. Now, to get y by itself, on the left-hand side, just like we did the other day, I'm going to do the inverse operation with our literal equations. I'm going to add 5 to both sides. So actually, let's write down step number 2. So after you distribute the slope, then you're either going to add or subtract from the y value. In other words, isolate the y. All right, so down here, again, I'm just going to copy this. Try to keep it organized for you. All right, so if I use inverse operations, that means I'm going to add 5 on this side. But I also have to add 5 to the other side so we can get that y-intercept. All right, so now we end up with y equals 9/13 x. And then I have all of these fractions to contend with. So this is honestly the most annoying part of solving these, but it gets easier after we do them a couple times. Okay, so you fraction lovers, Mina, that's you. We get to add fractions. So if I'm going to add fractions, remember we need to get a common denominator. So I have plus 5. All right, I'm going to think of that as 5 over 1. Well, my common denominator here is 13. So if I multiply the denominator by 13, got to do the same for the numerator. So that becomes like 65. All right, so now we can add those together. So -9 plus 65 is 54 over our common denominator of 13. All right, now check this out. This is where it's kind of cool, where it all comes together. So my y-intercept here is a positive 54 over 13, which probably doesn't really mean much to you. Okay, but, if I take 54 divided by 13 and see what that is, look at that, 4.15. And if you go back up here, we estimated our y-intercept to be 4.2. That's a good indication that we did our math right. So the whole process took a little longer than estimating, but honestly, sometimes, especially when we get into the math world, we can't just use approximate values. If you're approximating the distance over a bridge and we estimate it to be off by 0.05, that's a big deal. Okay, and so a lot of times the skills we're learning here help us when we come into the designing and architecture and engineering world to be more precise.